Hello everyone, welcome to another video in our Kubernetes series. Today we are going to discuss a topic that regards the usage of Docker in Kubernetes, okay? And I'll post this on the description of the video, but there's a link for a blog post that was published by the Kubernetes team where this topic is addressed, okay? But you should be asking yourself, but wait, Docker runs on Kubernetes, right? So why are we even having this discussion, okay? There's a bit more to it, so let's get into the nitty-gritty details, okay? So in the first or earliest versions of Kubernetes, there was no CRI, so no container runtime interface, okay? Which pretty much is a contract for our runtime, okay, to run, okay. Pretty much you can think of this container runtime interface like the interfaces on your code, okay. So you create an interface, it's a contract, it's something abstract, and then you have specific implementations of that interface, okay. In this case, the CRI, it's the interface for the container runtime. Okay, but back in the days when Kubernetes started, there was no CRI. Okay, there was no interface for the container runtime. Okay, and the runtime itself was coupled with Docker. Okay, so back in the days when Kubernetes started, the runtime for the containers was Docker. So the containers would run in the Docker. Okay. Now, the Kubernetes kubelet had Docker-specific code to manage the container lifecycle operations, okay, like pulling images, starting containers, etc., etc., okay. And at this time, okay, in the early stages, Docker was the default and the only supported runtime, okay, which meant that Kubernetes was heavily reliant on Docker. It was tightly coupled with Docker, which, if you think about it, kind of limits the flexibility that Kubernetes has. Okay. And then the Kubernetes team, as Kubernetes grew, they wanted to be, as agnostic as possible, even when it came to the runtime interface, okay, or to the underlying container runtime, okay. Then what happens as time goes by is that the Kubernetes team, they start to see the limitations of being coupled with Docker as far as container runtime. And they start to go on a direction where they want to be decoupled from Docker. Okay, they want to be generic, they want to be abstract, okay? And so they create this container runtime interface, the CRI, as I told you before, an abstraction layer or a contract layer that pretty much states, like the interface in our code, what is the behavior that is expected from a container runtime, okay? Now, Docker, okay, as the Kubernetes team creates this runtime interface, so this contract, this abstraction, Docker was still supported as a container runtime, but through this tool called Docker Shim. Okay, Docker Shim was an adapter that the Kubernetes team, okay, maintained. And that adapter would translate the container runtime interface calls into Docker API calls. Okay, so pretty much whenever I would call my interface method, let's think like code focused, then I would call the Docker Shim API itself, which in turn would call the Docker API. Okay. Now, the point with introducing CRI, okay, was so that we were not dependent on a single container runtime, but rather have support for multiple container runtimes besides the Docker one. As an example, you will often see today containerd as a container runtime or cry-o as a container runtime. And so the moving on this direction was a smart move, I would say, by the Kubernetes team. And as I told you, the container runtime for Docker, okay, Docker as a container runtime, it was still supported, but all the maintenance was done by the Kubernetes team. Okay, so they had the burden to support Docker as a container runtime. Okay, which means of course a bit of extra work for the Kubernetes team. Okay. Now today, and this is the link that you saw on the first slide, Docker Shim is no longer maintained by the Kubernetes team. Okay, and Docker is no longer supported as a runtime. Okay, so as you can imagine, imagine you being on the foot or on the shoes of the Kubernetes team. You have a container runtime, Docker, that belongs to a different company, let's say, and you are doing all the heavy lifting to have that container runtime supported on your platform. But then you have other container runtimes which are, let's say, obeying the rules and implementing this container runtime interface directly, which makes running those container runtimes much easier on Kubernetes. Okay, I mean, it comes to a point where the Kubernetes folks, they just say to the Docker folks, hey, please make this yourself. Please have support for, or at least implement the container runtime interface, or else Docker will no longer be supported as a container runtime. Okay, I believe that there was this exchange, but the Docker folks, they just said, okay, I don't care. And so what happened is what you see on this slide was that the Kubernetes team, they gave a notice period that from X date the Docker was not going to be supported as a container runtime anymore. And so this is the case today that we have. Okay, but does this actually mean that I cannot use Docker anymore just because Docker as a container runtime, and the container runtime is like the framework that executes the containers? Let's think about this in a broad way. Okay, like it's like if you code in Java or .NET, okay, so it's the underlying quote-unquote virtual machine that allows you to execute the code, okay? So the container runtime for Docker, that part no longer exists, okay? But you can still use Docker in Kubernetes, but not as a runtime, okay? So, but let's speak about this now, okay? So, to sum up a bit, okay, we have the container runtime interface, okay, the runtime, the quote-unquote virtual machine, not a virtual machine, but coding language related analogy. And this runtimes is responsible for executing our containers, okay. I told you some example of container runtimes that actually implement the CRI, cry-o, one of them, and containerd. But actually you can use Docker, but when it comes to pods, okay, because pods, they need at least one Docker image to run, a container image to run. And those container images, they follow a standard as well, which is called OCI, okay, Open Container Initiative, which amongst many things specifies an interface for Docker images, for container images, let's say, okay. And the Docker images, okay, the Docker images themselves, they implement this OCI standard, okay, which means that in Kubernetes, okay, CRI itself executes Docker images because the CRI executes pods and containers, and it executes Docker images that have that OCI interface. And because the Docker images, they implement that interface, they can run inside Kubernetes, okay? So Docker, you can run Docker on Kubernetes, not as a container runtime. So actually the underlying skeleton where the pods execute, or ultimately the containers execute, but you can use Docker images that are executed by other container runtimes, because Docker images themselves, they implement this OCI interface, okay? This OCI standard, okay? And to sum up, okay, can I use Docker in Kubernetes? The answer is it depends. As a container runtime, no. But as something that is executing on top of the runtime, meaning a container, yes. So you can use Docker images on Kubernetes. You can use Docker as a runtime, okay? So this is a summary, okay? So in order for the containers to run in Kubernetes, they run on a container runtime platform that implements container runtime interface, CRI, okay? So our containers in Kubernetes, they run on a container runtime that implements this interface. This is just two examples of container runtimes that implement this interface. And the containers that this container runtime executes, they are based on a container image or a Docker image, broadly speaking. And this container image is based on the OCI interface. And you can have multiple container images, Docker being one of them, and you can also have Podman images that implement this OCI. Okay, and then our container runtime will execute these containers that are based on this image. Okay, so this information is a bit of trivia. Okay, not necessarily something that you actually. I mean, it's good to know, but it's not a must know about Kubernetes. But nevertheless, it's a fun fact that you can know about Kubernetes. Okay, hopefully you enjoyed this, and I'll see you in the next one. Bye.